in our different categories of our methods of physical control. Remember, originally we talked physical, chemical, mechanical. In a medical setting, you have to take into account when you're trying to decontaminate and trying to sterilize, as I've said, you have to take into account the nature, not only of what microbes may or not be present, but also the object itself. Can it handle heat? Can it handle chemicals? Can it handle? Will, residues remain? So when we look at the physical, first one, heat. Heat something up. Heat something up, you're going to destroy it. In microbiology labs, we use Bunsen burners, we use micro incinerators, you superheat your instruments to the point that whatever's there, microbial wise, all the bacteria will be incinerated, turned to carbon, ash. So we think, hey, when in doubt, just chuck something into the oven. Well, you have to take into account what is going to work better, moist heat, dry heat. When you look at moist heat, you're heating not only the air in the environment, in that enclosed environment of the oven or whatever, but what you're also doing is you're heating the liquid vapor that's present. You're heating the liquid vapor that's present, and turns out that liquid vapor is able to penetrate into the nooks and the crannies better than just heat will. So since the vapor in an enclosed environment will also increase the pressure. Because of this increased pressure, this better penetration of the, heated vapors, liquid vapors, if you're using moist heat, you don't have to get as hot. You don't have to, use the treatment. Your methodology, your method, shorter exposure. This is the basis of autoclaves. Autoclaves are nothing than an industrial-sized pressure cooker. Yeah, the same pressure cooker you use at home. Same pressure cooker you use for cooking, or other types of pressure cookers you use for canning. The principle is the same. You raise the pressure in a sealed environment. You raise it up, 4 or 5 times atmospheric pressure. By doing so, you're also able to raise the boiling point of water. So instead of 100 degrees Celsius, it's now going to be 110, 120. So you're now getting more heat out of the water and the water vapor, which can penetrate into the nooks, the crannies better. Autoclave takes 15-20 minutes. Depending upon what you're doing, it can be shorter, could be a little bit longer, but 15-20 minutes. Versus if you were to use an oven, it's going to go dry heat. It's going to have to take much higher temperatures than 100 degrees Celsius, 120 degrees Celsius, and it's going to take much longer times. What we find is when it comes to the moist heat, the true damage, the true killing, comes in the form of protein denaturing. Remember, all the proteins in a living cell, whether it's prokaryotic, eukaryotic, have to maintain secondary, tertiary, quaternary structure to be a working protein and an enzyme that has activity. Shape dictates function. You interfere with the shape, you lose function. Denaturation due to moist heat means that the protein completely unravels. If it unravels, then they start to coagulate. The proteins will then start clumping together. Denaturation Coagulation, irreversible. Can't uncook an egg. Literally, that's what you're doing. You know, when you cook an egg and you sit there and watch it go from a clearish liquid to white opaque, you denature the proteins and you force them to coagulate. Well, moist heat, that's what you're doing, but you're doing it at the cellular level. Now, when you're looking at dry heat, much higher temperatures. Much higher temperatures and way longer times. You look here at table 9.4. Moist heat in an autoclave, basically going to be about 121 degrees, 15 minutes. Some things you may want to go a little higher, and if you do, 134 degrees. Look at that, 3 minutes. 3 minutes is enough to denature and coagulate all the proteins present in all the microbial cells. All the endospores will also be damaged and killed. To get relatively the same thing from dry heat, look at the times. 121 degrees Celsius, dry heat, you're going to have to go for 10 hours. 170, well, only an hour. That's baking temperatures. If you're wanting to bake a cake, that's basically what you're looking at right there. Dry heat, basically there is some denaturation present, but the majority of the damage you see with dry heat is evaporation, removing all the water present. Now, yeah, some endospores, some vegetative cells can handle the removal of water, and when water comes back, the cells and the endospores just, good to go. But by doing it this way, the proteins are going to be denatured, the water is going to be removed, and this coagulated event, the cells are going to dry out irreversibly.